Hello, my friends of Cadre Labs. Welcome to this tutorial. In this tutorial, we are going to do a simple geochemical modeling of the mixing, okay, of two waters, of surface water and groundwater, and then we are going to analyze which is the species and the saturated index for surface water, for groundwater, and then for the mixing. Okay, so we start by in any word processor, notepad, no word how say block, well, whatever this utilitarian, then okay, so we are going to create a file. Okay, so let's start. Okay, do you remember that for Aquifer app every solution needs a title? Okay, so let's see, title surface water groundwater mixing. Okay, and this is surface water. Okay, solution one. Okay, so let's see, we make a detection of four spaces. Units is in millimoles. Okay, this is based on the a data set over a lake. So and they use millimole per liters as the units. Okay, they don't use milligram per liter, and Phreeqc allows you to use millimole per liter as well. Okay, the alkalinity is 7.1. The chloride 1, chloride 1, 2, 3, 4, 0.8. The sulfur 24.4 as sulfate. Okay, this is actually not necessary. Okay, but well, we can also state that the sulfur is as a sulfate. Okay, sodium 11.1, magnesium 18.5, uh, calcium 3, potassium 1.2. Okay, save solution 1, and then we end this one. Okay, then we have solution 2. Okay, and there is the title of solution 2, and the title for solution 2 is this is groundwater. Okay, and the units are as well units millimole per liter. Then we have alkalinity of 12.5. We have chloride of 2.3. 1, 2, 3, 4. 2.3. We have sulfur of 1.8.5. Then we have sodium of 80. Then we have magnesium 11.5. Then we have calcium of 10.4. And then potassium with 0.8. And then we save this as solution. Save solution 2 and okay, and then we mix those. Okay, so let's say, and the mixing will be a mix. Okay, one, because this is the first mixing, and it will be 60% of surface water. So it will from the solution 1 0.6, and the for solution 2 0.4. Okay, and then we end here. Okay, so okay, for every solution there is a title, and all the solutions end with n. Okay, and this should be okay, and then we save that with the extension. Okay, so this is surface water, groundwater mixing, surface water, groundwater mixing dot in. It has to be dot in. Okay, and then here we go to the I'm going to delete the okay. Okay, let's see. Okay, now let's go to aquifer.hatarilabs.com. We logged in. Okay, then we add a project and the project will be mixing. I strongly recommend to use small names. I mean, not try to avoid the spaces, because even that it works with the spaces, I would like that it being avoided, because that could bring some errors on the path. Okay, yeah, so this will be mixing, and this is surface water slash groundwater mixing. Okay, then we upload that. Okay, we did. Remember that in Aquifer app you can also make paper plots. Okay, so we go to Phreeqc. Okay, oops, you shouldn't see this. Yeah, and I think this is because of the history. Okay, so you choose something like you see something like this, but I think that there are some things on the cache. Okay, so let's go here, and then let's go here, the surface water, groundwater mixing, upload. Okay, so this is the solution that we have inserted. Okay, so then we go to setup, then we go to Phreeqc, we select Phreeqc as the database, we run it. Okay, and it has run very well, and then we do compilation. When then we do the compilation, okay, we can see the raw results here. For this is for surface water, for groundwater, and this is for the mixing. However, we have these amazing tools here where we can see the composition. Okay, the alkalinity, the calcium, chloride, and so on. As we see, sodium, sulfur, sodium, and magnesium are the main species. Okay, and then comes alkalinity for surface water. Okay, the percent error is minus 4.37. Okay, and then we have the distribution of carbon as bicarbonate, then carbonate, calcium as calcium ion and calcium sulfate, chloride as chloride ion, potassium as potassium ion, magnesium as magnesium ion and magnesium sulfate, sodium as sodium ion, and sulfur as sulfate or as a magnesium sulfate. Okay, so this is the distribution for surface water. Let's see that for groundwater. Okay, from groundwater we see as well sulfur, sodium, and magnesium, but the alkalinity is smaller respect to the. Okay, could be. Okay, it could be. Let's see the solution composition here. No, solution composition. The alkalinity here is in the order of 0.007 10 to the minus 3. Okay, and let's see here. This is even higher. Okay, in groundwater is even higher. However, the concentrations of sulfur, sodium, and magnesium are even more, even higher than that. Even okay, great. So let's see the species distribution by element. Ah, okay. So by element we have here the um, the carbon is as bicarbonate, then it comes as magnesium carbonate. Calcium is as a calcium ion and calcium sulfate. Chloride, potassium, magnesium as magnesium sulfate. Sodium as uh, sodium ion, and from the sulfur is mostly as sulfates. Okay, but let's see what happens with the mixing. Okay, and the mixing, yeah, we have carbon, okay, and then we have sulfur, sodium, yeah, and alkalinity is on this order. Let's see about the description. The percent error is 2.48, okay, and the species distribution, okay, where we see the carbon as bicarbonate and some carbonate, the calcium as well is even as calcium plus 2 and calcium sulfate. Chloride is as chloride, potassium as potassium ion, magnesium as magnesium sulfate, sodium as sodium ion, and sulfur as sulfates and magnesium sulfate. Okay, so this is the mixing. Okay, so we have done in this tutorial um, the elaboration of the Phreeqc input file. We have inserted that into Aquifer App, and once we have inserted that into Aquifer App, we have simulated, we have selected database, we have simulated, and then we have analyzed, okay, what we have analyzed the speciation and the solution composition and the saturation index. The saturation index for, I mean, mostly are the same. I mean, it's really unsaturated with respect to ammonia and to H2S and to sulfur, and is almost in equilibrium with anhydrite, aragonite, and calcite. Okay, so and this is this is the result um, of the simulation. Um, and as you can see, Aquifer App is very handy to do this kind of simulation because it doesn't bring you not only the result, I mean, it simulates the Phreeqc file and it brings you the result, but it also makes you the tables and the charts that make you analyze, that are handy to analyze the impact of the mixing or the with respect to the initial solutions. Okay, we are from Hatari Labs. Hatari Labs is a website for knowledge sharing. We have an e-commerce site, shophatarilabs.com, where we have courses in Python, in SWAT, in but we have also diplomas, and these diplomas are complete material that go from the ground knowledge to the mastering in Model Muse, in FlowPy, or in SWAT. Okay, so and remember that by taking our courses, you are supporting our research. Okay, thank you for following us and hope to see you in coming tutorials.